Okay, this time I'm going to do something a little different. The next part of the explanation of how the synthesizers work is a little bit more difficult to visualize. And while the rocket does have this function, which is basically the low frequency oscillator, it's not quite as obvious as to exactly what it does and how it works. So I'm going to use the Game Boy with the Korg DX10 Plus cartridge to simulate a Korg MX synthesizer. Now, the old Korg synthesizer was basically a patch cord. And in order to use the different functions, you would connect the output of one section to the input of another using a patch cord, which is where the word patch came from. Now, with the game, we can connect the output of the low frequency oscillator to the input of some of the other circuits and visually see where that connection is going. It'd be a lot more obvious if this was an actual piece of hardware. We could physically hold the patch cords, but this is about as close as we're going to get. Unfortunately, because it is a small screen, the result may not look that good on the video, but we'll see what I can do. The difference between an audio oscillator and a low frequency oscillator is initially with the analog circuits. They were completely different designs. The audio oscillator, you want to go from maybe 40 hertz to 2K hertz. With the low frequency oscillator, you want to go from one cycle every 15 seconds to maybe 20 or 30 cycles a second. And that's not the same design for the two. And to differentiate between them, the original designers referred to the audio oscillator as oscillator 1, oscillator 2, and the low frequency oscillators as LFO, LFO 1, LFO 2. The rocket has two LFOs, and there are 6 destinations each. There's only one set of controls for the two, so we have to choose between LFO 1, LFO 2. We have rate, we have amplitude, and we have the waveform. And then the output of each LFO would go to one of the other circuits. And we'll see a little bit more about how that works on the simulator. So we've got LFO 1, LFO 2, and 6 destinations for each. We've got rate and amplitude, amount, and the wave shape. There's only one set of controls, so we have to choose if we're going to be setting the values for LFO 1 or LFO 2. The purpose of the LFOs is to automate what would otherwise be a manual process. So if I were to take the pitch and change it I don't want to do that as individual steps. I want the synthesizer to make that transition for me. Conversely, if I wanted to use the filter and I wanted this kind of action, which is a triangle wave, I don't want to do that manually. I want to be able to set some automatic function and have the synthesizer handle that for me. And that's what the LFO does. we have the Korg simulator running on the Game Boy. And with the keyboard, we have a relatively complex waveform that is a combination of a square wave and a triangle wave with about a 50% mix and a little bit of resonance in order to get something that sounds a little bit more interesting. Now, if we turn on the sequencer and we change the filter, now what we want to do is automate this. So if we go to the patch, we have three main waveforms like we did with the audio oscillator. We've got the sine wave, or we've got the triangle wave, the square wave, and the sawtooth. Rate controls the speed of each of these waveforms, and then what we want to do is feed one of the waveforms in to one of the inputs, such as pitch or frequency cutoff. Speed the rate up a little bit, go back to the keyboard, and now the low frequency oscillator is changing between two frequencies using the waveform that I selected and the rate, square wave, in order to change pitch. If I then feed a different signal into the cutoff filter and turn the keyboard back on, change the frequency a little bit. We're getting a frequency sweep using the low frequency oscillator with a square wave. If we change that to a sawtooth, it would be the same as if we were manually changing the cutoff frequency. We were just turning the knobs. One of the things that's kind of interesting about this simulator is that instead of using the keyboard, we have access to the Chaos Pad interface. Which will change the gating speed or the note frequency. The main idea here is that the LFO can be used for automating the process of changing the controls that we want, such as pitch or frequency cutoff, without our having to do it ourselves. And that can then be used as a patch setting later on for more complex waveforms. And we could, if we wanted to, use more than one. So we can combine a pitch sweep with a frequency sweep and get some really bizarre effects. The only drawback with the simulator is that we only have one rate. So if we wanted to have the pitch sweep at, say, a 10 hertz rate and the cutoff frequency sweep at a 1 second rate, once per second, we can't. We only have this one setup, this one rate control. But in terms of being able to see how to use a synthesizer and what the different hardware elements do, the simulator here is really, really good. This is a great learning tool. If you can find a used copy of the cartridge and you already have a Game Boy, I definitely recommend buying it as soon as you can. Okay, how does that apply to the Rocket? The Rocket, as I mentioned before, has two LFOs, LFO1, LFO2, but only one set of controls. So we have to specify which one is going to be controlled at any given moment using the LFO switch. And then we specify the destination with this switch. If I want to do a frequency sweep, first I'm going to go into drone mode. And in drone mode, attack turns into pitch, decay is pattern, sustain is volume, and release is pattern rate. And then I could do a frequency sweep manually. So instead, let's go to a straight square wave, and using LFO1 with the frequency output, change amount, change rate, and change the wave shape. And if I wanted to combine that with LFO2, and LFO2 can change the rate for LFO1. So the entire point of the LFOs is to automate the process of changing the front panel controls. Rather than you doing it by hand, you can now set up the synthesizer to do that for you. So that's LFO.